Hello boys and girls, this is the first video in the rock cycle series. This is all about classifying rocks. So a scientist who studies rocks is called a geologist, and when classifying rocks, a geologist will look at the mineral composition of the rocks and look at the colour and the texture of the rocks. So there's 5 criteria for a mineral. So all minerals must be formed by processes that occur in the natural world. They must be inorganic, which means they cannot come from any materials that are living or were once living. They have to be a solid, so they have a definite shape and a definite volume. They have particles that line up in a repeating pattern or a repeating structure, which forms a crystal. And they have a definite chemical composition. There's characteristics that help scientists classify different minerals. And they are colour. Colour is used to identify a few minerals that have their own characteristic colouring. So colour is used to identify a few minerals, like this beautiful blue azurite. Streak is the colour of a mineral's powder, and scientists find out what the streak is by scraping the mineral on an unglazed ceramic tile. So you can see there how each of these different minerals has a colour streak there. Lustre is how light is reflected from a mineral's surface. Like pyrite is has a reflective surface. Density, like how heavy a mineral is. So gold is an extremely dense mineral. It's very, very heavy in comparison to, say, a different mineral which is a lot lighter. Each mineral has certain characteristics. There's 4 more characteristics. The next one is hardness. Scientists use what's called the Mohs hardness scale that ranks the hardness of crystals from 1 to 10. Talc is the softest mineral and diamond is the hardest. The crystal system, that's how the crystals grow atom by atom to form a particular structure. They're grouped into categories based on how many sides they have and the angles of each crystal. Cleavage is if a mineral breaks easily along a flat edge. Like this mica, as you can see that there's little layers there that you can lift up layer upon layer. And fracture is if a mineral breaks apart in an irregular way, like this obsidian. When you break an obsidian, it breaks apart in very strange, peculiar ways. So minerals can be formed in 2 ways. The first is through the crystallization of magma or lava. So minerals form as the hot lava cools inside the Earth's crust or as lava hardens on the surface. So this is, you can see the different minerals in this piece of granite. So there's a bit of quartz, there's feldspar in there too. And sometimes you can have crystallization of minerals that have been dissolved in water. So if an element or a compound is dissolved in water, like a sugar solution or a salt solution, for example, some minerals will form when the solution evaporates and forms crystals. So if you're going to do a crystal experiment, the easiest one would be to make salt crystals or sugar crystals by making a sugar or salt solution and then letting that evaporate. So this is a copper sulfate solution that has left to evaporate and cause these beautiful, beautiful blue crystals. So geodes are rounded hollow rocks that are often lined with a crystal structure. Geodes can be created in the hollow areas of soil, such as animal burrows or tree roots. Excuse me, they're also formed in the bubbles in volcanic rock. Over time, dissolved minerals seep into a hollow area and harden into an outer shell, creating the geode. So if you've been to Thunder Egg Park or Thunderbird Park, you might have gone looking for geodes which looked like this, and maybe they had crystals inside them. A geode that is completely filled with crystals is called a nodule, and that's a beautiful amethyst nodule right there. I think that's the end of this video. Let me just double check. Yes, it was. Okay, thanks boys and girls. I'll catch you on the flip side.